Hi, my name is Adrian, and in this tutorial video I'm going to show you how to use one of the functions of the R package Influential for the visualization of ExIR results. And if you are not familiar with ExIR, it is a versatile one-stop model for the extraction, classification and prioritization of features from experimental data. According to a previous tutorial video, I demonstrated in detail how to run the ExIR model on experimental data and a sample experimental data actually, and accordingly we generated some results based on the ExIR model. So according to the same results, let's see how we can visualize them with the purpose of generating a publication quality figure. First, let's load the Influential R package and let's have a look at the ExIR model results. And as you can see, we have 4 different tables corresponding to 4 different classes of features, including drivers, demediators, non-demediators, and biomarkers. Next, we can simply visualize the ExIR results according to the ExIR function of the Influential R package by inputting only a single argument, which is the output of ExIR model. And we also specify the n, which indicates the number of top candidates that should be visualized within each class. So let's run the visualization function and let's have a look at the results. And as you can see, a beautiful figure is generated. It is almost ready for publication. And let's have a look at the different parts of the plot. It includes a title and a subtitle. And the subtitle indicates that it is a rank-based selection of top 5 candidates. On the y-axis, we have the features, and in this case, gene names. We have different classes of features in different panels. And within each panel we have the top 5 candidates of features, and on the x-axis we have the rank. And as you can see, the features are sorted according to the rank. And at the bottom of the figure we have the figure legend, which includes the types of features and also the z-score and statistical significance, which corresponds to the size of dots within the plot. But this is not the end, and a complete flexibility has been provided for adjustment and optimization of all of the features of the plot. And you can also select, for example, your desired class of features, your desired type, etc. So let's see how we can adjust the plot. The first parameter or argument is Synonyms Table, and it is quite handy when you want to show different names or synonym names of your features. Suppose, for example, your experimental data have been based on ensemble gene names, and you have run the ExIR model according to that experimental data. So you have ensemble gene names, but you can provide a data frame that includes 2 columns. The first column should include the original names, and in this scenario, the ensemble gene names, and the second column should include the synonyms, for example HGNC gene names or NCBI gene names, or whatever kind of synonym that you would desire to visualize within the plot. So for this purpose we generate a sample data frame of synonyms, and as we know from the previous tutorial video on how to run the ExIR model, our experimental data includes 1000 genes. And if you look at the head of the gene names, these include gene 1, 2, 3, etc. So let's create a synonyms table that includes 2 columns. The first column is the same gene names, and we name the second column as new names, or you can name it whatever kind of name that you would like. And we paste just the new at the beginning of each of the gene names. And let's have a look at the synonyms table, and as you can see, the word new has been added at the beginning of the name of each gene. So let's provide the synonyms table we just generated and run the ExIR with function again. And as you can see, the name of features has been changed into their synonyms according to the synonyms table that we provided. The next argument is driver type, and as you can see at the bottom of the plot in the legend, we have two different driver types, accelerator driver and decelerator driver, and you can specify if you want all of them, which is a default option, and it is named combined, but you can select only accelerators. And as you can see, the decelerator drivers have been removed from the plot, and the drivers have only been selected based on the accelerator drivers, and these include the top 5 accelerator drivers. And the next argument is biomarker type, and it is similar to driver type. You can select whether to show both, and actually select top candidates based on both upregulated and downregulated biomarkers, or select the top candidates based on only upregulated or downregulated biomarkers. And the next argument is show drivers. It indicates that whether the driver class should be visualized within the plot or not, and if you set it to false, as you can see, the driver section is removed from the plot. And the next argument is show biomarkers, and it is similar to show drivers. You can remove the biomarkers from the plot. And also the next arguments, including show demediator and show non-demediators, do the same, similar to what we did for drivers. And the basis indicates that whether the candidates should be selected based on the rank or their adjusted p-values. And by default, it is set to rank. And .min size and .max size indicates the min and max size of nodes within the plot. The min size by default is set to 2, and the max is by default set to 5. If you set the max, for example, to 8, you would see a much clearer distinction between dots with higher ranks and dots with lower ranks. And yes, and the other argument is type.color, and this indicates the color of the borders around the dots within the plot, and the borders or color of the border indicates the type of feature. For example, if it is an upregulated biomarker or downregulated biomarker. And you can set the default palettes provided, including viridis, plasma, magma, etc. But you can also set your desired color or desired color function to specify the color of stroke or border around the dots within the plot. So let's, for instance, change it to magma and see how these colors would change. And yes, and as you can see, the colors have changed to magma palette. And the next argument is stroke size, and the stroke size indicates the border or a stroke around the dots within the plot. It is by default set to 1.5, but if we set to 3, for instance, we can see that the type of features would be more clearly noticeable within the plot. And the next argument is stroke alpha, and stroke alpha indicates the transparency of border around the dots. and it is by default set to 1, but you can change it to, for example, 0.5 to make it more transparent. And the next argument is dot color low and dot color high, and as you can see, the z-score is actually ranging from blue to red colors, and blue indicates a lower z-score and red indicates higher z-score, but you can define your desired colors for low and high z-score. You can also specify the legend position. It is by default positioned at the bottom of the figure, but you can set it to right, top, or left. And you can also specify the legend direction, actually the direction of each of the legends within the legend box. And they are by default visualized vertically within the legend box, but you can change it to horizontal. And the next argument is legends layout. It is by default set to horizontal, so that different legends are set horizontally beside each other, but you can change it to vertical if you would like. And the next argument is box legend, and it indicates whether there should be a box around the legend or not. And it is by default set to true, as you can see, but if you change it to false, the box would be removed from around the legend. And the next argument is show plot title, and it is set to true, so that the plot title is shown, but if you set it to false, no plot title will be written above the plot. And you can also change the plot title. It is by default set to auto, and it means that it automatically generates a plot title for the plot. And the title position indicates that whether the title should be positioned on the left, right, or center of the plot, and it is by default on the center of the plot. And the plot title size indicates the size of the plot title or the font size of the plot title, and it is by default set to 12. You can increase or decrease that. And the show plot subtitle and plot subtitle and plot subtitle position are similar to what we just explained about the plot title. And the Y-axis title indicates the title of the Y-axis, which by default is feature, but we can change it to whatever kind of title we would like. For example, we can change the plot Y-axis title to gene. And the last argument is show Y-axis grid, and as you can see within the plot, we can see the Y-axis grid, but if we set it to false, the Y-axis grid is removed from the plot, and the plot would be more clear. But sometimes it is not desirable, because when you have a long list of features, you would like to more easily track which gene corresponds to which dot within the plot, and having the show Y-axis grid set to true would make the plot more readable. And that's it, and hope you find it useful and use it for visualization of ExIR model results and generate beautiful figures for your manuscripts.